All today in this video I'm going to make a demo video for linear SVM with regularization parameter. Already with the same code we have worked with some different kernel with SVM like linear, sigmoid, RBF and uh, polynomial kernel. Apart from that, previously we worked with only kernel. Now we are going to make use of regularization parameter, that is C. So we are using the same data set previously we have used, which is heart disease data set. This data set we downloaded from Kaggle. You can just give us heart disease detection Kaggle data set. In that case, you will get downloaded this data set. This data set is having nearly 14 entries, and the first 13 entry will be used as the x variable, and the last variable, that is the target variable, will be used as the y variable. Then we are getting the info of the data set, whether it is string or integer or float type. Then we are checking whether our data set is having any null entries. If it is having any null entries, means we have to work with some pre-processing function. Since our data set is not having any null entries, we are moving to the getting the shape of the data set, and then we are making a plot. Within the plot we are making use of the target variable. A target variable has two parameters like 0 and 1. We are making a plot that which parameter is high, and based on that we are making a graph. Then by using the train test function and the x variable and y variable with the test size of 0.2, that is 20% for testing and remaining 80% for training, we are making determining variables like x train, x test, y train and y test. Then linear kernel already we have done with the SVM. So for that we are importing the library which is needed for SVM. Then we are calling our function, and within that SVM function we are calling the kernel as linear, and then we are training this linear SVM by using the fit function and testing by using the predict function, and then we are determining the confusion matrix and also the classification report variables like precision, recall, F1 score and support, and we have got an accuracy of 85%. Then we worked with the sigmoid kernel, and here also we have trained and tested the sigmoid kernel, and we have displayed the confusion matrix and also the printed the classification report parameters and got an accuracy of 54%. Then we worked with the radial basis function kernel SVM, and then we are trained and tested this radial basis function SVM kernel, and then we have displayed our confusion matrix and also printed our classification report. Then we have worked with polynomial SVM kernel, and then we have trained and tested our variable, and then we have displayed the confusion matrix, and then we have got the printed the classification report and got an accuracy of 70%. From this four kernels we have in this, with this particular data set, linear kernel is providing better results. So within this linear kernel we are making some regularization function. Initially we have given us 1.0 only, and then as like a previous we are training and testing this linear kernel with the regularization parameter as 1.0, and then we have displayed the confusion matrix and printed the classification report parameters and have got an accuracy of same 85%, which we have got in linear kernel without using any regularization parameter. So in the next video we will be working by increasing the regularization parameter. We can see like whether increasing or decreasing the regularization parameter is providing any improvements with the accuracy value. Then we are making a comparison. For comparison we are determining all the models within a single variable called models, and then here we are making a for loop, and within the for loop we are calling this variable models, and then fitting the function, training or function, and also we are determining some parameters like accuracy, mean square error, R2 square, etc. And then we are declaring the training accuracy and testing accuracy, and we are making two print the training accuracy and testing accuracy, you can notice that the training accuracy and testing accuracy of every model is displayed over here. From here, you can notice that the accuracy of linear SVM and linear SVM with regularization is more or less the same only. Then we are making a table comparison. Within the table comparison, we have set an highlighter point that the model with the best accuracy will be shown with the green color and the model with the least accuracy will be shown with red color. Here you can notice through models are showing green color. Why? Because linear SVM and linear SVM with regularization is showing the same result. Why? One that only it is showing two models are showing green color. So after linear SVM, this polynomial SVM takes the place. After comes the radial basis function SVM and finally the sigmoid SVM. In the next video, we can work with some other regularization parameter. So based on that, we can just make a conclusion that increasing the regularization parameter whether increase the results or else it is same only. Thank you.